Hello everyone, hope you are doing great. You are watching Code with Shubhajit and today we will be discussing one of the problems from lead code which is valid parenthesis. I want to tell you at the start of the problem that you will be learning a different concept here where I will be explaining you that how in certain conditions what type of data structure can be used. I will be giving you the intuition in that problem today. So please be with us and let's go through the problem statement and see what they're trying to say. Okay. So we are given a string S containing the characters opening and closing parentheses, curly braces, and square brackets. Okay, so these are the 6 type of characters which we have, and we have to determine if the string is valid. There are 3 conditions which says if the string is valid or not. You can just read through them, but I will explain you through the examples. So can you see here that whenever there is an opening parenthesis of any type, there should be a closing parenthesis of the same type. Okay, or I can say there is some opening bracket of any type. Maybe it is a parenthesis, a curly brace, or a square bracket. There should be a closing one. Okay, apart from that, there should be equal number of opening and closing brackets of same type. Okay, apart from that, order is also important. Why? Can you see here that after an opening parenthesis a closing square bracket is there? So this is not valid. So I hope if you have done a bit of math and you know how brackets work, then you should be able to understand what the problem statement is trying to say. So whenever these type of situations occur, when it is not a valid set of brackets, then we should have to return a false, else we will be returning true. Okay, so here in this string you can see that this is a balanced parenthesis. Opening, this is the opening one, this is the closing one. This is the opening one, this is the closing one. Same way, opening and closing, respectively, they are happening with the same type of brackets. Okay, but if we take something like this is wrong. Why? Because here we will be needing a closing curly brace, not a closing square bracket. Okay, a lot of examples have been done. I hope this is pretty much clear. Now let's understand how to go about it. Okay, so giving you the intuition a bit. Okay, can you see that whenever we will be traversing over this whole string of like brackets, what we will be seeing that whenever we have a opening bracket, I don't have to do much, because whenever an opening bracket is encountered, it's fine, just be with it. But in cases where a closing bracket occurs, which is this one, okay, then we have to see what is the previous opening bracket or whether it is an opening bracket or not. Okay, let me index that. Okay, so I have indexed them out. What I'm saying is the index 3, the bracket at index 3, it will check whether it is of same type as of index 2, as well as we will also check that it is a opening bracket or not. Okay, so there are 2 checks which we need to make, same type and opening one. So when this is done, then this part, I will totally ignore this part because here balance is restored. Okay, now I will come to this. It is an opening bracket, fine. Now this is a closing bracket. I need to see the previous bracket, the previous index, whatever the bracket is, it is of same type. That is the first thing. The second thing is like opening bracket or not. Yes, it is an opening bracket, also of same type. So this part also I don't need to worry about. Now square bracket, closing square bracket comes. Now if you see that as I have ignored these parts, and I need to check it with the part which is still not ignored, which is the index 1, because you see the index 2 to index 5, they are all ignored because the balance has been restored there. But on index 6 we have a closing square bracket. We have to see that before index 6, which is not ignored till now, is there a opening square bracket or not, because an opening type as well as of same bracket type. Okay, so they both are matching here, so that's why we will ignore this 1 and 6 part as well. Now the pointer moves at the last closing parenthesis. We will just check that whatever part is not ignored till now, so this whole part index 1 to index 6 has been ignored because the balancing has been restored there. And now we will check with index 0. Is index 7 and index 0, the elements are of same type? Yes, they both are parenthesis. And is at index 0 the opening type is there? Yes, opening type is there. So this whole string is actually balanced. So you might remember that at the start of the video I have told you that I will be giving an intuition of some data structure which you might need to use whenever such type of scenario, if you are able to see in some logic. Okay, so I will be explaining that intuition now. Just hear to this properly. So can you see, whenever we are traversing over this whole string of characters having different types of brackets, parentheses, okay, all that, you might have noted that we have a pointer which is moving from left to right. But at certain point, we also need to check. Let's say for us, we need to check index 6 with the index 1, okay, which is very far back. And we don't have anything to point that whatever the last unignored part is, okay. And whenever we have to go to the left, not the immediate left, but a certain left, and we need to pull out that element, in that case we will be using a data structure called stack. Okay, so I will explain a bit about stack first, and then we will see that how stack will help us in this problem. So here we have a stack, and stack works by the principle of last in, first out, LIFO principle. Whoever the last is in, that is the first person to be out. Let's say what I'm saying. So in the stack I put this, then in the stack I put this, and in the stack I put this, after that I put this. Okay, now this is the first element, this is the second, third and fourth. But when I have to put it out, which is the element I can like pull? It is the last element. So that's why last in, first out, or it is first in, last out. Because the first element which is put in, it will be taken out at the last. So that is the basic structure and principle of stack which I have explained you. Now let's see how stack will help us in this logic which I have just explained. Okay. Okay, I have taken the array again and also indexed them out. So now I will be using a stack, and I will also explain you while traversing this how it is filling the stack and how it is coming out of the stack. Okay, so we will start a pointer with an index 0 and we will go till the index 7. Okay, so our pointer, let's take it as I, it is at 0th index. Okay, so whenever we see an opening bracket, we shouldn't care much about it, because an opening bracket, adding that is just fine, because we need to just check. The main part is when a closing bracket comes. Whenever a closing bracket comes, we need to see that does it have a matching pair of opening type in a particular order or not. That is our main task. Okay, so here, as it is an opening bracket, I will put it into the stack. So I will put this into the stack. Good. Now I increments here. Opening bracket, I will put it here, no problem. Opening bracket, I will put it here, no problem. Good. Now what we have a closing parenthesis. So whenever we have whatever of closing type, we will check at the top of the stack that is that element is of same type as of this. Yes, this and this, they are of same type. Okay, fine. So currently I'm at this element. So I will check, is this element, that is at index 3, whatever the closing parenthesis is it as the same type as the top of the stack? Yes, it is. Apart from that, is it of open type? Yes, it is. Good. It means that I can ignore this part. So what I will do, I will just pop it out of the stack, and now I don't have any element like this here. Okay, good, fine. Now I will start traversing again. Now an opening curly brace came, so I will just put it into the stack. Now a closing curly brace came, so again the same thing, they are definitely of same type. So what I will do, I will just pop it out of the stack. Okay, it's done. Now the pointer moves here. Now when it moves here, and you can see that till now we have this part, this whole index 2 to index 5, it's ignored. Why it is ignored? Because it has a balanced part, so we don't need to see what is happening there. So now we have index 6. Now we have to go back to the part which is not ignored, which is the index 1. How will we know that? We will know that because we have a stack. Because I have popped out the elements which are balanced, now the top element which I have is the unignored element only. So this is the main intuition of using stack in this logic. I hope you're able to understand this. And this will actually help you in a lot of problems in future where you see this type of pattern. Okay, let's continue that. So we are at index 6 and we see that, okay, this element, the closing bracket, square bracket and the opening square bracket, they are of same type. So I will also remove this part. Okay, and now my pointer will move here, which is an opening closing parenthesis. So when it is closing parenthesis, I will check that, okay, do we have an opening type of opening bracket of the same type? Yes, we have an opening bracket of the same type, and thus I will also remove this parenthesis. I hope you are able to understand this whole logic. And this is the last element. The pointer comes to the last, it comes out of the for loop. The last thing which we need to check is the stack empty or not. If the stack is empty, it means the whole string is properly balanced. If the stack is not empty, it means that there is something which is not balanced. I will also show you an example. Okay, so when the opening parenthesis comes, I will just put it as it is. When the opening curly brace comes, I will just put it as it is. Then a closing square bracket came. So the closing square bracket I will check with the top element. Are they of same type? No, they are of not same type. Yeah, it is open, I can say that, but they are of not of same type. And if they are of not of same type, then I will just return false at this point only, because I know it is not a balanced parenthesis string. I hope you have understood the whole explanation. Go through it once again if you are not. And now we will code out the whole solution. Okay, coming to the coding part, I have initialized some of the things like the stack and also written some of the methods, which are some basic methods. I will explain you what they do after writing the program. This is the initialization of a stack in Java. After that, we will be running a for loop. So for int I is equals to 0, I is less than s dot length and I plus plus. Okay, so we have to take the character at the index I. So what I will do for that, char ch is equals to s dot char at I. So this is how in Java we actually extract a character out of the string given the index I with the help of char at method. Okay, so once we get that character, we will check that if the character is of opening type. As I have explained you, the character, if it is opening type, I don't care anything. I will just push it to the stack. So if is of opening type, then I will just push the element to the stack, push the character to the stack. So what does this is of opening type do? As it's very obvious, it will check that whether the character which has been passed here as parameters, it is one among parenthesis, curly braces or square bracket, opening type. Okay, so if it returns true, then I will push the character to the stack. Good. But if that's not the case, then I definitely know that the character is not of opening type. It definitely means that the character is of closing type. Okay, because we have either of characters opening type or of closing type in the string. So if the character is of closing type, then we have to check. I have forgot to explain you one condition. If the starting character is only of closing type, then the stack would have been empty, right? And if the stack is empty and we are gonna check that, okay, the top of the stack and whatever element we have now from this for loop, are they of same type? That will give an error. So we will also need to check that if the stock is empty, okay, I think for empty it's this. Okay, if the stock is if the stack is empty, in that case, or else not of, I think I should copy it from here, is of same type. Okay, not of is of same type. What are the characters? The opening and the closing characters. So what is the opening one? The opening one should be present in the top of the stack, so it should be stack dot peak. So stack dot peak will give us the top character of the stack. So if I go here at any point, I am saying this character. Okay, that is the top of the stack. St dot peak will give. What is the second character? Second character is this ch, what we are traversing through, the string. Okay, so either case, if our stack is empty, or the character which we are traversing now is not of same type as the top of the stack. So what's the is of same type do? It will return true only if both the characters which we have passed are of same type. Either be parentheses, either be curly braces, either be square brackets. And if that's not the case, I will return false. So here I'm checking that if they are not of same type, I have put a not condition here. You have to just remember that. So if they are not of same type, or either if the stack is empty, and in that case a closing bracket comes, then I will return false, because I know definitely it's not a balanced uh, parenthesis string. Okay. Okay, so after the if and else if condition, what is left? You can see that it's not of opening type. Good. You can also see it means that it is of closing type, but now the closing type is actually of the same type, so that's why return false hasn't happened. And if they are of same type, what I will do, okay, I will just pop that element from the top of the stack, because I have found a pair, and that's why I will just remove it, because a balance has occurred. I hope you are able to understand that it actually resembles the code part only. So let's say this is there, right? So if after this, let's say this thing come, then what I will do, I will just remove this part, right? And my top position will be at this opening parenthesis. Okay, this is the thing which we are doing here, st.pop, which will pop the top element from the stack. Okay, now at the end, we will just check that whether the stack is empty or not. If the stack is empty, it means a balanced parenthesis is there, else a balanced parenthesis or balanced bracket string was not there. Okay, regarding the time and space complexity, so if you see that in case of this, we are taking a stack as an extra space, right? So this stack will be filled based on the number of elements inside this string S, okay? So due to this, the space complexity has become a big O of n. And with respect to the time complexity, can you see that we have a for loop here? Okay, and this for loop is going through every character once, and then we are doing the further process, okay, which is actually of constant time only. I am taking these method calls as constant time only. So this for loop is the linear loop which we'll be having, so that's why the time complexity which we will be having is big O of n as well. I will just run this and see if there are any errors which has occurred. Okay, all the test cases pass. I hope that you are able to understand this. The using of stack and why to use it, I have given you the intuition. You might be able to use this in some other problems where the logic is kind of same. And I highly encourage you to submit this problem and see if all the test cases pass. I will also suggest to dry run the logic on some different examples, some random examples, and then you can understand more how the logic is working. Okay. And that's all for today, guys. If you have any doubts, put them in the comment section. I will be really happy to help. Thank you.